Hello, sixth graders. Today we're going to talk about combining like terms. And what do we do with terms that are the same? Well, our first job is to remember that, guest appearance. Okay, get down. Get down. All right, sorry, we had a guest appearance there. All right. First thing we have to do is look at what are our like terms. What are terms and what are like terms? Well, if we remember from a couple lessons ago when we looked at our terms, we looked at terms being the things that made up the algebraic expression. So we had the terms and we listed them. Well, like terms are terms that are in the expression that have the same exponents, that have the same variables that are raised to the same exponent. So like terms are just terms that have the same variables and this can also include constants. All right, now that we have the definition written down, let's see what this means when we are actually using it. Okay, so like terms are terms that are the same. So terms that are the same. That is what we're going to be looking at today. Terms that are the same. All right, but how do we combine them? So let's go ahead and look at what this actually looks like in action. So I have a math problem. Don't I always? I have a math problem and it looks like this. 3x plus 9 plus 2x minus 5. All right, as I'm looking at this math problem, I can see that I have many different terms. I have a 3x, I have a 9, I have a 2x, and I have a negative 5. So my terms that I have are just simply putting a comma in between each of these things, right? Those are my terms. Well, the terms that are the same are the ones that have the same variables. For example, I have a 3x and I have a positive 2x. Those are the same terms because they both have an x that's to the power of nothing. So because they both have an x, they are the same terms. So I'm going to take that 3x and that 2x and I am just going to put them down right there. Next, my dog really wants to do math today. All right, now I'm going to look at the next things. I have these these constants right here. I have a positive 9 and a negative 5. Both of these constants are the same. They don't have any variables, but they are the same because they're both a constant. Our guest is gone. Okay, so now because these two are the same, they're both constants, we're going to write those down here separately. Okay, so we've started to organize our work. So we've started to organize the terms together so that the ones that are the same are all together. So our first step here in this problem 1 is to find the terms that are the same. Step 2 we did, after we circled them or shaped them up, right? We organized our problem here. We rewrote them together. So rewrite together. Now we're going to finish out with the combining part. So I'm going to take my 2x and my 3x, and I'm going to add those because this sign tells me to add. This tells me now that I have 5x. I'm then going to add 9 minus 5. So 9 minus 5 is 4. So adding 4. This problem right here is done. I cannot put a 5x with a 4 because this one is a coefficient and this one is a constant. So I put the coefficients with coefficients, constants with constants. I'm done. This problem is now complete, and we call this step 3, which is to simplify. We've combined the things that are the same. You cannot put green with orange. Those two things cannot go together. Okay, that's done. We're finished with this problem. Somebody else will come along behind us. They will tell us what x equals, and then we can put it together and solve it. But until we know what x is, we cannot solve this problem. We've just kind of organized all of the terms. We've taken something that's super messy, we've organized it, and then we've simplified it. Okay, let's do another example. So here is another example. This example, looks like this. All right, so now we've started to look at having multiple terms. So we're going to go through and we're going to put the things together that are the same. So I'm going to start by looking for W's. This has a W, this has a W, and this one has a W, but this W is different because it's squared. So this W we're not going to include in our two W's here because these ones are just plain W's. So we're going to rewrite this as 7W plus 3W. Now I'm going to continue on my journey here, and I'm going to put things together that are the same. There's a constant, and again, that one doesn't matter. It still has a W squared on it. So I'm going to put plus 11 minus 4. Those terms go together. They're both constants. And then my last problem that I have is going to be this plus 4W squared. That one is going to be separate because of the squared. Okay, so now we're going to combine the things that are the same, and we're going to just go ahead and simplify this. So I'm going to first start with 7W plus 3W. That gives me 10W's. My next part of this problem, as I simplify it down even smaller, is I have 11 minus 4. Well, I know that 11 minus 4 is 7. So I have a plus 7. And last but not least, I have this one all by itself. W squared. And the reason why I'm allowed to move these numbers is because of the commutative property. So the commutative property that you learned about in elementary school tells you that you can move things around by using addition or multiplication. All right, and they keep their same value when you do that. Okay, we're going to do another example. Example C. This example says y plus y plus y plus y. We're going to combine the things that are the same. Now, if we were multiplying, we would have exponents. But because we're not multiplying here, we are adding. We're going to put all of the y's together. So in this problem, I have 1y, I have another 1y, I have another 1y, and another 1y, for a total of 1, 2, 3, and 4. So this tells me that I have 4 y's. It's not multiplication, so you're not putting it as an exponent. If this were an exponent, these y's would need to be multiplied. Okay, let's do one more that's just like this problem here. We're going to call this example D, so that way you can see once again how this goes together. So in this problem, I have B plus B plus B plus 6. That is a 6. I probably should have chosen a different one. They use a 6 in their problem. I don't know, but that 6 does look like a B. Okay, again, I'm going to go through and I'm going to combine the things that are the same, add them up. I have 1, 2, 3, 4, 5 B's. So 5 times B, because remember the 1 that's in front of here is invisible. We can't see it, but it's there. It is there. Plus, I have this 6 over here that's all by itself, and I'm going to stop. This problem right here is complete. Again, I cannot put 6 and the B's together because I don't know what B is. Once I multiply and know what B is, once this coefficient does its job, then we can add in the 6. But until then, we just leave it just like this. Again, just like this, just leave it. This is your final answer. You have an expression. This one up here, you don't combine those things. They're not the same. You leave it just like that. All right, it is your turn for some try-its. Are you ready? Are you ready for some try-its? Yes, the answer is yes. Yes, you are ready. Okay, in your try-its, try-it number 1. Try-it number 1 says 8 plus 3z minus z. So you're going to put together the things that are the same, combine like terms. Try-it number 2. Try-it number 2 says 3 plus b plus 5 plus b plus 2 plus m. Oh my goodness. Okay, so go ahead and combine your like terms. Hit pause so that you don't hear me solving these, and then when you are ready, come on back. All right, so in this first one, I have a 3z and a negative z. So if I have 3 minus 1, because remember that 1 is there, that gives me 2z's. This 8 is just going to be by itself, so we're going to write plus 8. So 2z plus 8. If you wrote 8 plus 2z, that's okay. That is the same thing. We're just going to use the commutative property to move that 8 behind so that way you write it correctly. Algebraic expressions should be written so that the variables come first and then the constants at the end. All right, this next problem, let's circle the things that are the same. I have a 3, I have a 5, there's another constant, and I have a plus 2. I'm going to put those together. So I have a 3 plus 5 plus 2. All those constants are together. All right, now I'm going to go for my letters. What variables do I have? I have a B, and I have another B, and I have an M. Not the same thing. So I'm just going to put plus B, and last but not least, I have an M. So I'm going to put plus M. Okay, now I'm going to continue on my journey here of putting things together that are the same. My dogs are really fussy today. I am so sorry about that. All right, so we have 3 and 5 is 8, 9, 10. So that gives us 10. Plus I have 1b plus 2, that's 2 b's. So I have 2b or not to be. That is the question. Plus I have this m. All I'm going to do now is just rewrite this problem so that my 10 comes at the end by using the commutative property to move things around. So this problem should be 2b plus m plus 10. That is my final answer for this one. Again, if you wrote it like this, that's okay. Try to get in the habit of commuting your numbers that can commute using the addition property and moving those numbers around. All right, go ahead and answer your essential question. How do we combine like terms? So find somewhere on your paper. I'm going to have to go off here to the side. So answer your essential question. How do we combine like terms? And then go ahead and put your level of understanding out into a box there. 1, I have no idea what you did, Miss Eglander. You just have shapes all over your paper, and I am so confused. 2, I can see how you're putting some things together and some things not together, but I really want to solve the problem, and so I am having a hard time not solving this. So maybe you're at a 2, or maybe you're at a 3. Maybe you're totally great with this. You're able to put the things together that are the same and just simplify it so it's not so messy. Go ahead and rate your level of understanding. And then when you are done, you may go on back to the Google Meet to ask for help, or you may go and work on your practice work. As always, thank you so much for all of your hard work and effort today. I so appreciate it, and make it a great day.